Welcome, everyone. Today, we're diving into platform engineering, a discipline that's reshaping how organizations build and scale their technology infrastructure. We will explore what platform engineering is, its key concepts, and the platform engineering objectives that drive its adoption. Be sure to watch all 4 videos as part of this series. So, let's get started. Before we go too deep into detail, let's review some definitions. What is platform engineering? It is the art and science of designing, building, and managing self-service platforms that enable developers to deploy and operate applications efficiently. It bridges the gap between developers and infrastructure, empowering teams to focus on delivering value without being bogged down by operational complexities. This definition is taken from the Microsoft Learn site. According to Microsoft, platform engineering is a practice built up from DevOps principles that seeks to improve each development team's security, compliance, costs, and time-to-business value through improved developer experiences and self-service within a secure, governed framework. Let's take a few steps back and learn about the history of platform engineering. Around 2007, the IT industry faced a critical turning point. Reports highlighted a fatal level of dysfunction between IT operations and software development communities. This dysfunction stemmed from the dev versus ops divide, where development teams prioritized speed and innovation, while operations teams focused on stability and risk management. This misalignment led to bottlenecks, inefficiencies, and a growing frustration across organizations. The industry began to realize that traditional siloed approaches were inadequate for the rapidly evolving demands of software delivery. To address these challenges, the DevOps movement emerged, emphasizing collaboration, shared responsibilities, and automation to bridge the gap between development and operations. While DevOps principles made significant strides, they also revealed a new challenge: the need for scalable platforms that could standardize and simplify the adoption of DevOps across complex organizations. Leading tech companies like Google, Facebook, Airbnb, Netflix, and Zalando recognized the need to provide their developers with seamless access to tools, services, and workflows. They pioneered the development of internal developer portals, self-service platforms that abstracted the complexity of underlying infrastructure and made it easier for developers to work autonomously. These portals became the backbone of platform engineering by streamlining processes, enabling reuse of infrastructure, and reducing friction for developers. The success of these developer portals inspired more organizations to invest in platform engineering teams. Platform engineering began to evolve into a discipline focused on creating self-service, reusable platforms that aligned with the unique needs of their developers. Open-source solutions like Backstage, Spotify, and frameworks for building developer portals started gaining traction, making these concepts more accessible. In 2022, platform engineering and internal developer portals were recognized by Gartner as one of the top 10 strategic technology trends. This marked a turning point for the industry, as businesses across all sectors realized the strategic importance of building internal platforms to support innovation, speed, and developer satisfaction. Platform engineering was no longer confined to tech giants. It became a priority for organizations aiming to compete in the digital era. Today, platform engineering is at the forefront of IT innovation, with dedicated teams and tools designed to enable developers to focus on delivering value, not infrastructure. Developer portals have evolved into comprehensive internal developer platforms, IDPs, providing everything from environment provisioning to CI and CD pipelines in a unified interface. Platform engineering is widely regarded as a critical enabler of productivity, scalability, and operational excellence in modern organizations. Thanks for watching. This is the second video in the Platform Engineering series. In this video, we will review platform engineering according to Gartner. The diagram of platform engineering from Gartner provides a high-level overview of how platform engineering operates within an organization. Here's a breakdown of the key components based on the diagram. Product and service teams, the consumers, are the end users of the platform, such as developers, product teams, and service teams, who consume the platform's offerings. They rely on the platform for delivering software efficiently, without needing to manage the underlying complexity of infrastructure. The digital platform, the core of platform engineering, is the central enabler of platform engineering, consisting of the following. Reusable components, which are pre-built elements such as templates, configurations, and libraries that developers can leverage to reduce duplication of effort. Promotes standardization and consistency across projects and delivering value. Then we have tools, which refers to a set of technologies provided to developers, such as CI and CD pipelines, monitoring tools, and deployment frameworks to simplify and automate their workflows. Also included is platform services, services like authentication, logging, container orchestration, and environment provisioning that abstract the complexities of infrastructure. And finally, knowledge. This includes documentation, guides, and training resources to enable developers to navigate and utilize the platform effectively. These components collectively reduce friction and allow developers to focus on building and delivering value. The developer portal acts as the interface through which developers interact with the digital platform. It consolidates access to reusable components, tools, platform services, and knowledge in a user-friendly, self-service manner. Developer portals ensure ease of use, autonomy, and speed for the product and service teams. The infrastructure platform underpins the digital platform and is responsible for managing the complexities of hardware, cloud environments, networking, and more. It is abstracted from developers, so they can focus on application development without dealing with the intricacies of infrastructure management. Dedicated platform engineering teams are responsible for designing, building, and maintaining the infrastructure platform and developer portal. Their primary goal is to provide a seamless experience for product teams, manage and abstract infrastructure complexity, and ensure the platform evolves alongside the organization's needs. Thanks for watching. This is the third video in the Platform Engineering series. In this video, we will learn about Infrastructure as Code. Infrastructure as Code, or IAC, is a transformative practice that changes how we manage and provision infrastructure. With IAC, you write every setup and configuration as code, and they use automation tools to orchestrate and provision infrastructure automatically. In other words, you write your infrastructure as code once, and then apply it automatically as many times to different environments as you need. In this example, we see a depiction of how infrastructure was traditionally managed. Here, individual team members manually interact with various components like databases, cloud services, servers, and networks. This manual approach was prone to several challenges, such as lack of standardization and inconsistent documentation, increased risk of human error when setting up or managing environments, and slow and inefficient processes that couldn't scale effectively. Now, let's look at the modern approach enabled by IAC. IAC automates infrastructure provisioning using code and scripts, allowing developers to interact programmatically with infrastructure components. Instead of manually configuring systems, developers now use automation tools and code-based processes to manage infrastructure. This results in a highly efficient, scalable, and consistent infrastructure setup. Let's go through these key benefits of infrastructure as code, which addresses the pain points of traditional management. Better documentation. Infrastructure configurations are written as code, creating a single source of truth that is easy to track and maintain. Reusability. Reusable code modules enable teams to standardize and replicate infrastructure components across environments. Increased speed and efficiency with automation. Infrastructure provisioning is faster, enabling teams to deploy environments in minutes instead of days. Reduced costs. By eliminating manual processes and optimizing resource usage, IAC reduces operational costs. Increased scalability. Infrastructure can be scaled up or down dynamically using predefined code, ensuring flexibility to meet changing demands. Less human error. Automation minimizes manual intervention, reducing the likelihood of configuration errors. Better collaboration and visibility. IAC fosters collaboration across teams by enabling everyone to work from the same, well-documented configuration files. Disaster recovery out of the box. With IAC, environments can be quickly rebuilt from code, ensuring rapid recovery from outages or failures. In summary, infrastructure as code enables us to work smarter, not harder. By treating infrastructure like software, we unlock efficiencies, improve reliability, and set the foundation for scalable, modern IT operations at Genmab. Thanks for watching. This is the fourth and final video in the Platform Engineering series. In this video, we will learn about the developer experience, the developer portal, and open source considerations. At the heart of successful software development lies the developer experience, DX. This concept emphasizes how developers interact with the tools, platforms, and processes that enable them to build and deliver software efficiently. The goal is clear: to make developers work smoother and more enjoyable, because happy developers are productive developers. The concept of developer experience is also about designing the tools and processes that developers use to build software and ensuring that they are efficient and satisfying to use. A good developer experience leads to more productive developers, better collaboration, and faster software delivery. Platform engineering is focused on optimizing the developer experience by providing the right tools and best practices to enable developers to work effectively and with a high degree of satisfaction. A good developer experience encourages collaboration, improves the speed of software delivery, and makes it easier to enforce security and compliance controls. With that said, software development teams are dealing with more complexity than ever. They've moved from monoliths to microservices, seen an explosion in APIs, started to explore generative AI tools, and often work in a distributed environment. Developers are being asked to manage everything from security vulnerabilities to cloud configuration, which leaves little time for writing code. Teams are being asked to do more with less. Maximizing productivity is the order of the day. The trouble is that knowledge worker productivity is notoriously difficult to quantify, and as the saying goes, you can't improve what you can't measure. There's a significant body of research showing that happy workers are productive workers. So it makes sense that we focus on what makes them happy and instill within them a deep sense of fulfillment that comes from creating something great. Let's talk a little more about the developer portal. A developer portal is an essential tool for any organization that wants to make it easy for developers to integrate with their software and services. It is a self-service platform that provides all the APIs, documentation, code samples, and SDKs that developers need to build integrations into their applications. By providing access to well-organized, easy-to-use, and up-to-date content, developer portals can help companies attract and retain developers, enabling them to build better applications faster and drive innovation and growth. And finally, let's review some open source considerations. Although not currently being utilized at Genmab, Backstage is a good example of an open source framework. Originally created by Spotify, it is now a project under the Cloud Native Computing Foundation, CNCF. It is designed to be developer-friendly, with clear, concise, and well-organized content, so developers can quickly find the information they need and get started building applications. Backstage helps organizations manage their complex software ecosystems more efficiently, enabling faster and higher quality code delivery. Following inner source principles can also be highly beneficial when building and maintaining a framework like Backstage. Inner source is a software development methodology that applies open source practices and principles to internal projects within an organization. It encourages collaboration and sharing of code, tools, and best practice across different teams and departments. We hope you have enjoyed watching the Platform Engineering 4-part video series. Let us sum up with the objectives of platform engineering. These objectives align with the overarching goal of enabling developers and organizations to deliver software faster, more securely, and with greater efficiency. Let's break them down one by one. Increase infrastructure delivery speed. The first objective is to accelerate how quickly infrastructure can be provisioned and made ready for use. By leveraging automation, reusable components, and self-service tools, platform engineering enables teams to move faster and meet business demands with greater agility. Improve the developer experience. Platform engineering prioritizes creating a seamless, intuitive experience for developers. By removing friction in their workflows, providing access to well-integrated tools, and ensuring consistency, we enable developers to focus on writing great code rather than managing infrastructure. Reduce cognitive load. Modern development environments are increasingly complex. A key objective of platform engineering is to reduce this complexity by abstracting repetitive tasks and simplifying decision-making. By reducing cognitive load, developers can work more effectively without being overwhelmed. Provide DevSecOps best practices and tooling aligned with security. Security is a non-negotiable aspect of software delivery. Platform engineering integrates DevSecOps practices into the platform to ensure security is baked into every stage of the development lifecycle. This includes providing secure-by-design tools and workflows that align with organizational security policies. In summary, these objectives form the foundation of a successful platform engineering strategy. By achieving these goals, we not only empower developers, but also enhance the organization's ability to innovate, scale, and deliver value securely and efficiently. Thanks for watching.